Hello and welcome to another one of Dee's ADD videos. Today we're going to look at an example of a partial fractions integration problem. Again, the concept is that we're going to take this problem that no other technique seems apparent, recognize the fact that the denominator is factorable, and then try partial fractions. So step one is always to factor the denominator if it's not already factored. Right, and in this case, we're going to get factor out the x that's common. To figure out what's left behind, you take what you had originally over what you're factoring out. So in this case, if you go off to the side, you had an x cubed. You're factoring out an x, so your x squared had over factor. Alright, so now step two would be to recognize the scenario. Which scenario is it? Well, this one actually is a combination of a quadratic, right, the x squared plus 4. Usually with the quadratics, whatever you do, we put an ax plus b or something along those lines on the numerator. And then just the next term, just a linear expression. So how would you separate that? Well, what I would do is I would rewrite the problem like this. This is the first step in the decomposition of the fraction. The next step is, after you figured out the scenario and decompose, multiply both sides by denominator of the left side. So, I'm going to do that here. And by ending the bracket here, I'm showing that I'm multiplying it all the way through. So on the left-hand side, if you remember, I told you, if you watch the concept video, you're always going to be left with what? Just this numerator intact. Nothing's going to change. So we're going to have a 2x squared minus x. Oops, what's a funky looking x? Some people might have said that it looked like a 4. And then when I multiply the a, the x would cancel with the x, leaving me with the a times the x squared plus 4. And if I were to take this whole expression and multiply it times this, the x squared plus 4's would cancel, and I'd be left with the bx plus c times x. Alright, so if you remember the step after that, I told you guys to multiply and group the right side together, all the like terms. So mult right side and group. So that would be so then when you distribute the right-hand side, you get so what we're doing now is the fourth step. The fourth step is to distribute and combine like terms, group like terms. After that, we're going to equate the coefficients. So here we have a ax squared plus bx squared plus cx plus 4a. Factoring out the x squareds, I get a plus b times x squared plus cx plus 4a. Bringing this down, we get 2x squared minus x plus 4. And then at that point, if this equal sign has any validity to it, this a plus b must equal the 2, because they're both coefficients of x squared. So the first equation you would get is a plus b equals 2. The next equation, setting the coefficients of this x equal to the coefficient of that x. If there's no number there, it's a negative 1. You know that c equals a negative 1. And then finally, the numerical values, setting those two equal to each other, we get that 4a equals 4. If we divide both sides by 4, we get a equals 1. So if a equals 1, and I plug into this equation over here, I get 1 plus b equals 2, or b equals 1 as well. So what we've done is found these numerators for what the fractions were over here prior to you finding that common denominator. So what you can do is you can go plug back in and rewrite the problem into a new problem, which I've already taken liberty to do. And that's really all the new stuff there is with partial fractions. From here on out, it's testing your integration skills. So this integral here, how would you go about solving it? Well, you would first separate into two integrals because of that plus sign. Then notice that this numerator where this arrow is pointing and now this arrow that I just drew is pointing has a plus or minus. And you can always separate those. So create three integrals. The integral of 1 over x dx is equal to natural log of x. And then here we have the x over x squared plus 2. Well, that one there is a u substitution. Let u equal the denominator. Then du equals that, solve for dx, plug in and cancel. And then after that you get 1 over u du, which then integrates to ln of u. What was your u? Ln x squared plus 4. You can look at that again. That's the beauty of this video. You can always rewind it if you didn't get that. But that should be pretty straightforward u sub. If you don't get that, go back and look at the u sub video. And then this one is an inverse trig formula you should recognize. Anytime you have a box squared plus a squared in the denominator, that box being whatever variable, then it becomes 1 over a, tangent box over a, and you plug in chug, and you get that wonderful answer there. Alright, so what were the steps? Factor denominator, okay? First you tried u sub, you tried by parts, all those other techniques, that didn't work, so you notice denominator factors. Then pick the scenarios that apply the rules, multiply both sides by the denominator. Left side's always the numerator. Over here it stays intact, doesn't change. Right there. And then the right side you're going to cancel some of them aren't. And then you distribute what's left, group the like terms, equate the coefficients, create your new integral, integrate. Hope that has clarified any confusion that you might have. And practice, practice, practice. That's the best way to do these things. Thank you and have a nice day.